Welcome to Utilizing AI, the podcast about using AI in the enterprise. I'm your host, Stephen Foskett, and today we're talking about using AI as part of IT operations. As I said, I'm Stephen Foskett. You can find me at gestaltit.com. I also am the organizer of the Tech Field Day event series, and you can find me on Twitter at @sfoskett.
And I am David Aponte. I work as a machine learning engineer for Benevolent AI, and I'm also a host of the coffee sessions in the MLOps community. You could find me on LinkedIn, David Aponte, Aponte. Glad to be here.
Hey everybody, I'm Demetrios Brinkmann. I am the organizer of the MLOps community, and you can check us out at MLOps community on Twitter, or find me on LinkedIn, Demetrios Brinkmann.
So in enterprise IT, the whole operations world has forever been flooded by applications trying to basically accelerate the job of humans doing the everyday running of IT. The problem is that those jobs tend to be sort of inglorious. They deal with a lot of data. There's a lot of things that people are missing. And AI promises to really help that. And so today we're going to talk a little bit about the various ways that AI is coming, getting real, coming into the enterprise through the operations perspective. And I wanted to start with Demetrios because, heck, you run the MLOps community. This is your thing. And I know that this is your background as well. So tell us a little bit about how AI affects IT operations.
Yeah, so I think it could be nice to just start and explain a little bit about what MLOps is and how it differs from DevOps a little bit. And David can keep me honest on this point, but
Got you.
Yeah, you have a lot of similarities and crossover when it comes to MLOps, the operations side of machine learning, but there are quite a bit of differences because MLOps or machine learning is just a different beast. And so what you need to focus on when you're looking at MLOps are you have data, you have models that are being put into production, and models, I mean like machine learning models that are being produced, they're being trained, and then once they get put into production, it's not just as simple as maybe pushing software into production. And when it's out in production, you have those day two operations like monitoring, and you can find all kinds of bugs because it's not so easy when you're monitoring a system for, let's say, just regular infrastructure. You can tell, is it working or is it not? And when you're monitoring machine learning, you have many more factors that come into play. It might be working, but it might be giving you the wrong recommendations if you're using a recommendation model, or it might be giving you all kinds of it might just have drifted. We call that like model drift, which means that it's gone and it's done something that it shouldn't be doing. And when you originally trained it, you said it was going to do this, or you thought it would do this, and then it stopped doing that. So I'm not sure if David wants to add any other points on what makes it different.
I would also just add, it's just that element of data where the data is actually what powers the machine learning. So it actually makes it useful. It learns from the data. That's essentially what a machine learning model is, something that can learn from the data. And another, just to touch upon the point of how that relates to IT operations, how AI is changing that, I think it's affecting a lot of areas like quality assurance, service management, so chatbots, things of that nature, process automation. So it's definitely making use of all that data that maybe before had to be manually curated and like kind of look through. But now, if we have all this data, we could actually learn from it and make it useful and teach it how to do specific tasks. So I would just say that it's actually affecting a lot of different areas that may be easily automated, and some are more difficult than others because of that human component. But there's even the possibility of a collaboration between AI and humans. This field called active learning, where you're now having human in the loop, and that's a very important field too. But yeah, in general, I think it's changing a lot of things.
It seems to me like this is one of the, low-hanging fruit, as they say, of applications for AI, in that, one of the things specifically ML is good at is being trained to, find the needle in the haystack, being trained to look through a large volume of data and find the outliers, find the unusual things. And And then more interestingly, I mean, you could do that with a filter, you could do that with rules, but more interestingly is that ML can not only find the unusual things, but find the unusual things that you don't even know are unusual. Find the oddballs that you might not have trained the system to look for, which in areas like, you know, one of the big applications for this, for ML early on is security. It's just tremendously valuable because, you know, you may not know, or in fact, you probably don't know what the bad guys are doing to your system in order to get in, but ML might be able to say, hey, that's unusual. Is that the right picture? Is that the right way to look at the easy applications for ML?
I would definitely say so, yeah, because it's good at doing things that are repetitive. It's good at doing things that are, I guess, reproducible. That's what it's really essentially doing, is finding patterns in your data. And these are typically patterns that you wouldn't be able to identify, you know, just by looking at it or by even sorting through it. And so it allows you to, it augments your intelligence. You know, I think that even at my company at Benevolent AI, that's what we say about how it's affecting drug discovery. It's augmenting our ability to find hypotheses. So, you know, anyone can come up with a hypothesis, right? But the search space may be so large that it's not feasible to do by hand or even by a human. And when it comes to something like that, I think that's where ML is particularly useful, when it could actually automate something that is typically, you know, requires a lot of data, a lot of parsing, is maybe, you know, hard to spot these small little nuances. And yeah, I think, yeah, that's definitely a very, like you said, a low hanging fruit of where it's actually useful, anything that can be automated pretty easily.
And I think it's funny that you had mentioned the security space. I have a friend that I was just talking to, Ahmed at Safe AI, and he was saying what his product does is it makes data self-aware, so that in case things start going haywire, or in case like data starts acting like it shouldn't be acting, they look at it and they say, hey, is this a security breach? What's going on? And he's doing that with AI.
So is this realistic though? You know, I mean, that was always my thought when I was seeing companies, you know, present things. So for example, we do a security field day event, and at the security field day event, we had some companies talking about how they're using ML to do just simple things. You know, we're just monitoring the logs to see if anything unusual shows up. Is this realistic? I mean, you guys know this, you know, the world of models and AI and ML and deep learning and all this better than me. Is it really true that the systems will discover this stuff, or is it just more hype from the vendors?
That's a great question. Personally, I do think that there is a lot of hype around AI, around what it's capable of doing. As someone who actually builds this stuff, I know its limitations. And I will say it's only as good as the infrastructure that you have in place, the data that you're actually feeding it. So it's only, I guess it's feasible when you have a lot of these things in place. Like I mentioned, the infrastructure. If you have the ability to collect data that's actually going to be useful for the model, if there's some versioning around that, there's a way to organize it in a way that's useful and allow other people to make it even more useful, which in machine learning could be feature engineering. It's where you take a bunch of raw data, but you turn it into features or inputs that are actually going to be useful for the model. And it's very difficult to even get to that stage if you can't, you know, you don't have your data in one place. So I think it is possible, but it's not the type of thing that you can just throw at a problem and expect it to work. You have to have some infrastructure in place. You have to have even a cultural perspective on how to manage these things in place. And you also have to have people that understand how to, you know, regulate some of these things, because, you know, AI by itself could learn bad things. It could learn bias. It could be abused, you know, and that's commonly, you know, like for example, with fake news, you know, there's some really good algorithms that are good at generating fakes, and those are hard to actually detect. So I would say yes, you know, it's definitely doable, but you have to have certain things in place. And we could talk a little bit more about that if you'd like. But in general, I would say it's only as good as the infrastructure and the people and the data that you have in place.
Yeah, to that point, I think it's really interesting, because if you look at, I was talking to a VC who specifically invests in machine learning startups, and his whole thing was, it is really difficult to base your business around machine learning, because not only are the people that create the models and the engineers very expensive, but the actual ability to get it right, to be able to have a model that continuously gets things right when it is, you say, okay, I want AI or I want machine learning to do this. And then you go out and you build it, and you can continuously just like consistently make that model do that. It's very difficult to do that. So there are a lot of companies that set out with great expectations, but they get a bit burnt in the end. So I would say beware.
That actually brings to mind a question that I was thinking of is this kind of the opportunity for a new kind of vendor? In other words, instead of companies developing their own models for security or for monitoring or management or something, is there the opportunity for an entirely new kind of product vendor that consists of, and of course this is something that exists, but a new to IT kind of product vendor that consists of people who really know this space, trying to encode their intelligence and encode their experience and train models that can replicate that intelligence and experience in a certain way? Like, is it in a way, it's not really practical for, you know, a food manufacturer, an auto company or something to be doing this. Like, it would be better for them to rely on a vendor that specializes in network security or process automation or whatever to bring them a model. Is that practical?
Yeah, I think there's some people in this space, like, you know, I'm thinking about, you know, ML for ML. There's already people that are trying to automate machine learning and make it super easy, where it's at the click of a button, you can actually provide useful results. You know, I think of AWS, which has a lot of, fully managed services. Google, GCP, Google has a lot of fully managed services. So there's already people that are thinking about that exactly. How can we make it even easier so that you don't have to have a whole team of engineers and data scientists and AI scientists managing this thing? Is there a way that we can use things out of the box and apply them? I think so, for sure. But I would also say that I haven't seen that in my own experience work without people actually managing that. But I do think that over time we will get better. You know, it's like the more that we learn how to automate certain things, you know, the more we'll learn how to make it even easier for users to consume these models or to, you know, utilize this technology and embed it into their services. But yeah, feeding on the point that Demetrios said about, you know, it's hard for some companies to kind of, you know, throw ML at their problem. And when you try to build a company around just ML, it's a bit difficult. It's usually better when you focus on your domain and the problem that you're trying to solve, and then think about how AI can actually augment that, can make it better. But, you know, looking at it from the perspective of just kind of making everything easy, it's like solving all your problems, I don't think that's really the best way to look at it. I would caution that it's something that can help you, but you have to have certain things in place. And this even applies to those fully managed solutions. You still have to have some human in the loop managing that, because again, AI on its own can learn bad things and can actually, you know, cause problems. And some of them can be hard to spot if you don't know how to really look into them. And I'm sure maybe people will come up with solutions for that as well. But generally, I would say that, yeah, that's something that's a work in progress.
Yeah, and to that vendor point, I think right now what we see in the space are companies like auto ML companies that are trying to do something like that. They're trying to make it easier for the company that's not necessarily willing to go out and hire a huge data team and get all this infrastructure team for machine learning. They're trying to help with that. That being said, yeah, it's not there yet. There's a lot of people that are finding a lot of good uses from it, I think, but when you compare that to an actual team, the team is going to be much better in 99.9% of those use cases.
So let's talk about another thing that, you know, affects all of this, and that's sort of the infrastructure component. You know, David, I know that one of the things that you've talked about a lot is this whole world of, you know, that AI and ML, you know, it's a different kind of data than companies are used to. They're used to dealing with, you know, I mean, they like to talk about, oh, we're data driven, or we've got, you know, large amounts of unstructured data or something. This is an entirely different kind of data. Tell us a little bit more about that.
Sure. I think, you know, maybe to clarify a little bit, it's not so much that it's like an entirely different type of data. It's just the way that you deal with it and the way that it needs to be processed for it to actually be useful for the machine learning models. That requires some care and requires some science. You know, it's not just an engineering problem. Even before you get to the part where you actually like do some cool things with it, you have to actually manage it and collect it. That's the first challenge, you know, and depending on your use case, you know, for example, if you're a website where your machine learning model is making predictions in real time, or I could think about, let's say, some IT solution that's actually monitoring, you know, a real life system and needs to give you real alerts, that needs a database that can actually have low latency, that can actually pull that data in a way that's actually, you know, good for the model and it doesn't take a long time. But that's a little bit different from, let's say, like a data lake or a data store that is going to be used for training the model, developing it, but it can store a lot more things. It doesn't need to be as fast. So considering the different types of databases that you may need is an issue. Also collecting the right type of data, knowing how to I guess, find things that are useful, you know. And then the other component is once you get to the part where you have, let's say, a bunch of raw unstructured data that you think you could turn it to something for useful, is actually engineering it for inputs like feature engineering and making it even more useful, more structured, more specific for the algorithm. And depending on the algorithm that you're using, there's even a bunch of different techniques you could do there. I like to think of this sort of part as like kind of being arts and crafts and all like very sciencey and kind of you know, a mixture of different things. There's not really a well-defined way to do these things, but the component around knowing what to collect, how to collect it, that it's you're considering some of those components of the speed, right, at which you're getting it, the amount that you could store, and also, you know, that component of just making sure that you're actually processing it in a way that's useful. So again, it's not so much that it's not the same data, because I think of, let's say, just you have like some sensors that are just recording everything, right? That could actually be turned into a useful, you know, set of features for a model, but you may have to process it, normalize it, standardize it. I think about some of the things of like, let's say if you have a bunch of missing values, what's a smart way to impute those missing values? And that's where there's some more thought that it requires some more thought than just kind of just putting it into a model.
Yeah. And I've heard a statistic that, you know, 80% of a data scientist's time is doing that with the data, like transforming the data or cleaning the data. And the other parts are spent doing everything else, but that is a majority of your time. And just one little tangent that I wanted to mention before we jump on to the next question. I was talking to this guy, Vin, yesterday on the MLOps meetup, and he was really like a big proponent on monetizing ML and making sure you're getting ROI from this ML. And he talked about how, you know, if you don't have the data that you need to build a model and you need to go out and gather that data, that is a cost, and you need to look at that very clearly. And he made some very poignant points on this idea of really getting your model to be making you money from the very beginning.
So one final thing that I'll throw out here is, you know, especially in enterprise IT, where some of these terms are a little bit foreign and unusual and so on, I could forgive people for hearing ML ops and thinking DevOps and thinking that these are somehow, well, if not the same thing, at least the same category of things. But that's really not true, right?
Yeah, there are definitely some big differences. We had actually an episode about this a little while ago with Ryan Dawson. Shout out to Ryan Dawson from Selden. But what we talked about was, you know, there's this so let me just talk about at a high level some of the differences. So one is that you have data. So typical, you know, software development release, it doesn't have a huge data component. Like if you're storing your data in a GitHub repo or a GitLab repository, the data is not going to be stored there. It's going to be elsewhere. And so releasing, you know, data and thinking about that alongside the code itself is an additional challenge that needs a whole, you know, different set of practices. There's also this component of randomness. You know, algorithms sometimes have, they learn things and it's not always reproduced. It's not deterministic. And what I mean by that is there, like, for example, a deep learning model has some weights that it initializes randomly and it may be different every time. So there's that other component where you can't always reproduce the same results exactly in the same way, especially when you have a black box model like a deep learning model. model. And then there's the infrastructure in place. We were talking earlier about the need to monitor it when it's in production. You can't really monitor it in the same way as, typical software because of the way that what it's actually doing. It's generating predictions. You need to make sure that those predictions make sense, that there's some way to validate that their quality is good, that they're not drifting, that they're not changing because maybe the inputs change. Like, let's say, if you have some sort of seasonality, that's a part of your data set. All of these things need to be considered. And it's not that DevOps doesn't think about those things. I think they're very much related. So I would say, even at my company, the DevOps engineers, they know machine learning. They're very familiar with it. But their specialty is around just the software component. An MLOps person, or let's say someone that works in an ML infrastructure team, they're thinking about that same sort of software, but then there's also added element of complexity with the data, with the infrastructure. They need to monitor it in real time, or even in offline. So there's these other layers of complexity that make it a little bit different. But I would say, if you're familiar with DevOps, that's awesome, and it can give you a lot to work with. So I don't want to, say that they're so different in the sense that, there's no comparison, but there are some differences, the randomness, the data, things of that nature.
For me, it's easier to understand some of this stuff with stories or real life examples. And when you talk about monitoring and, okay, maybe something happens, and so now the model is not doing what it said it would do. And so there was a great story that helped me anchor this in my mind, which was, let's imagine that you have a model or some kind of AI that is looking at different pictures, and it's for a self-driving car, let's say, right? And so it sees stop signs, but what happens to that? So you train the model and everything is okay, it's working well. But when it snows, all of a sudden, the stop signs that it's seeing look completely different. And so it's not going to be able to predict that this is a stop sign. So that's something that when you're monitoring, that's what we would call like drift, right? It's because something happened and now, boom, your model is not doing what it said it would be doing.
Yeah, I would say traditional software maybe won't operate in that same way. There's, of course, applications that maybe don't have any machine learning that, you can regularly redeploy them, regularly re-release them. You could do a lot of things, and they're similar in the way that you would think about deploying machine learning models. But like you said, if it's being used for, like let's say self-driving car, I guess the stakes are a little bit higher around what it's doing. And there's even a lot of fields that are, that the stakes are really high. I would say for me in drug discovery, it really is, what it really is doing is helping us make the process of finding drugs a lot easier, hopefully, cheaper, and that it takes less time. But those decisions are really important. If we just decide to test these things, that costs a lot of money. And so if there's real decisions being made off of the outputs of these models, I don't know. I mean, I'm sure there's apps that obviously work like that, but I think it's that added element of the stakes are a little bit higher because of what it's actually doing, and the way to monitor that and the infrastructure around that is a little bit different. It's new, right? This hasn't been around for too long. DevOps and software has been around for a little while, but this new field of machine learning ops came up because it didn't exactly answer all the questions, right? Those old fields were an influence to it, but it just wasn't the exact same thing. And so we had to start developing new ways to think about this. But definitely a lot of overlap, of course, because it comes from that, it developed from these earlier fields.
Yeah, it's interesting to me that I see the analogy being more that IT needs to be more involved in development of software, and that's where DevOps came from. And similarly, the developers have to be more involved in the operation of their solutions that they come up with, and then that accelerates the pace of development. And in a similar way, it's the same with machine learning and AI generally, that, if this stuff is coming home, IT needs to get involved, needs to be involved, needs to continue to be involved. And the AI ML community needs to understand the realities of IT operations. And so in that way, they are similar, but generally speaking, they're not the same thing, that's for sure.
I love that you brought up that point. We machine learning engineers, data scientists, they should learn from these other fields, especially IT. You know, something that I particularly like learned more recently is the need, like security. Security is a big thing now, and I, you know, don't really care about those things because I just want to build cool stuff. But it's so important for me to understand that that component and why it's important, and how to, you know, how does that inform the way that I build things, or even maybe not necessarily, I don't have to do the security work, but at least I'm considering that, things like privacy. So yeah, I think that it's very important to learn from these other fields, to be cross-disciplinary as much as possible, to learn from others that are dealing with these things on a day-to-day basis.
Well, thank you guys very much. I think that that's where we're going to leave it here today. Of course, we'll be talking about this quite a lot more. Just to wrap up, you know, on this topic, where can people find more of what you're speaking about on the topic of machine learning and its effects on IT operations?
Yeah, if you want to dive into the MLOps community, you can see all kinds of good stuff. We've been recording weekly meetups for about 6 months now. And we've also been doing, like David said earlier, we've been doing coffee sessions, which are a bit more podcast style. And everything is on our YouTube channel. It's just, if you search for MLOps community, and that's MLOps, and you'll see basically the whole catalog, or you can find us on anywhere that you listen to podcasts. We're also on there.
Yeah, and I would just also add, if feel free to reach out to me. I love talking to new people. If any of you guys are interested in reaching out to me and learning, hey, how can I learn more about this stuff? Please reach out, and you know, if I can, I'll get back to you, and I'll point you to some good resources that were useful for me, that were really helpful for me in understanding this field, because, you know, I'm learning every day, and I want to remind people of that too, that this is it's a moving target. Things are changing pretty rapidly, and even practitioners who are in the day-to-day you know, trenches are still learning new things. So yeah, it's an ongoing learning process, and very much open to helping people kind of get up to speed or find good places to look, because there's so much out there. You know, there's a lot of content, and it's not all great in my opinion, but there's, you know, reach out to us and we'll try to point you in the right direction.
Yeah, that's a good point. I forgot to mention, if you really want to do a deep dive into this, you can check out our Slack community, which is MLOps community Slack. If you just go to mlops.community, you should be able to find the links to everything I just mentioned.
Awesome, thank you. And I have to say that, you know, it's really great to find a community of people that are just so enthusiastic and willing to help and willing to talk and willing to welcome new people in. And, you know, I really appreciate that. I really appreciate the fact that is when I reached out to the two of you, your first answer was, yeah, instead of, wait.
Yeah,
wait,
yeah, I love collaboration. I know Demetrios does too. And I think that's an underplayed, you know, thing in this space, where, you know, like, I just want to, last little point, like, you know, that I'm only as smart as the people who put out great content out there. You know, I'm completely unoriginal. Everything that I know has been from other people, and I want to give that back. I love when someone is, you know, writes a very clear article and explains something that's difficult, or someone's easy to talk to and can answer your question. And I think we need more of that. I think we need more openness for collaboration, more people that are willing to teach what they know and learn from others, and just having that, you know, sort of open source mentality. I'm definitely for that. I know Demetrios is, and the MLOps community certainly is as well.
All right. Well, thank you guys so much. This has been a really wonderful, wonderful discussion. If you've enjoyed listening to this discussion, please do head over to your favorite podcast app and subscribe to Utilizing AI. We are going to be recording more and more conversations like this, and I have a feeling that we're probably going to have these folks back on the in the future, because it's been a lot of fun.
I would love to. Yeah, I would love to. Yeah, this is such a pleasure. Thank you, Stephen.
So thank you guys very much for being part of this. Again, this is the Utilizing AI podcast from Gestalt IT, your home for IT content from across the enterprise. Thanks for listening.